Alright, so the first thing that we're going to look at is 3B. Okay, so 3B, all this is just looking at slope or rate of change. Okay, rate of change, slope, be the same thing. So look at number 1, is that the savings account balance can be modeled by the graph of the linear function shown on the grid. What is the rate of change of the balance with respect to the number of deposits? So knowing that rate of change is the same thing as your slope. Okay, so to find slope, how do you find slope?
Change over y over change over x.
Change of y over change of x. Good. We also can say rise over run. All of them mean the same thing. Okay, so if we look at our graph, we need to do our change of y. So we're going from one point to the next. I'm going from 50 up to 150. How much is that? 100. And I go over to my next point, which is 50. Which is 1. Okay, so then my change of y was 100 over my change of x we found was 1. So which one would be my answer? A. Good. Okay. Making sure that we're paying attention to our scale on the side. If you do not, well, no, we're going to go ahead and say that. Okay, number 19. So 19 is actually the exact same thing. Says the table represents some points on the graph of a linear function. What is the rate of change of y with respect to x? So again, rate of change means slope. And we know that slope is the change of y over the change of x. So if we go to our table, if we look at our x's, how do I get from -2 to 0? Plus 2. How do I get from 12 to 3? Minus what? 9. Minus 9. Okay, now I have my change of y and I have my change of x. So my change of y is -9 over my change of x is a +2. So I go to my answer choices and B is my answer. Question on that. Okay, if you don't, you can also in your calculator, if you look at your blue sheet, the star chart, and you go under these linear equations, one of the lines has slope of a line, and it tells that your slope is equal to y2 minus y1 divided by x2 minus x1. With that, you can also just plug in points and just put that straight into your calculator. Okay, so if I put in my calculator, I can put control, divide, and it gives me a fraction. And I can type in y2, so 3, minus my first y, which is 12, divided by 0, minus my first x, which is a -2. And type that straight into my calculator. And it does all the work for me. Okay, so I can do it that way either. Okay, next page. Okay, for 38, it's asking which of these best represents the rate of change in the gas sample with respect to the temperature. Okay, so the first thing you're going to have to look at is the scale of the x and the y. Okay, so if I look at this scale over on my y's, it goes 20 up here, goes by 25. So what do you think that each one of these little lines is going to be? 1, right? This will be 21, 22, 23, 24, 25. Okay, so every single line that you see is going to go by 1. Okay? If I look at my x, I have 0, I have a line, 1, 2, 3 lines in between, and it goes to 20. So, if we look, this line right here is right in the middle. So what do you think that line's going to be? It's right in the middle between 0 and 20, so it's going to be 10. So this one would be 30, 50, 70, 90. Okay, so each side is going by 5s. Okay, and then our second step is going to be to pick 2 perfect points. Okay, so we're going to look for 2 perfect points that we think that are exactly on the lines themselves. So the lines I chose were at when my x is 30. It looks like it's right on the line. That it touches an exact point. And then also it looks like at 90, when my x is 90, it's touching an exact point. Okay, when it says best represents, if I choose a point that is not exactly on the line, and I still do my work, I'm going to get close to an answer. Okay, so it's a little bit easier. Now, my third step is to set up my change of y over my change of x. And then my 4th step is going to be to use the calculator. Now, when putting it in my calculator, on our blue sheet, we see it's y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. So if I look, we're going to say this is point 1, and this is point 2. Okay, what is the y value of my point 2? We know it's going by 1s. What's that before 30? 29. So 29 minus, what's the y value of my first point?
24.
24. Divided by, what's the x value of my second point? 90 minus, what's the x value of my first point? 30. So I'm going to go to my calculator. I'm going to go back home. I'm going to go to calculate. Now, to be able to get into my fraction, I'm going to put control divide and make my life a lot easier. Now I just have to type it in exactly as I wrote it. So 29 minus 24. Oops. 29 minus 24 and 90 minus 30. Enter. What do I get? 1 over 12, which is answer choice D. Questions on that one? Okay, quite a couple steps, but we'll always get you the right answer. Okay, next one. The graph models a linear relationship between the temperature of Earth's atmosphere and the altitude above sea level. Which of these best represents the rate of change of the temperature with respect to altitude? So we're going to do the exact same thing that we did. We know that rate of change, same thing as slope, and slope is change of y over my change of x. So again, I'm looking where are exact points that I see, or close enough, right? So where do you think? Or points that might look the exact same.
Where y is 10.
Okay, so 10. Well, y is 10. Go here.
Where y is.
Oh, is that not right?
Okay, y is 10. So let's use those 2 points and see if we can get what we got. Okay, so if I use these 2 points, they're close, right? They're not exact, but it's saying best represents. So if I look, what is my, so remember it's y2 minus y1 over x2 minus x1. So what is let's say this is 1, this is 2. What is my y value, my point 2? Negative 30 minus, what's the y value, my point 1? 10 divided by, what is the x value minus point 2? 7 minus, what's the x value of point 1? 1. I'm moving my diagram to see does it square. Give me something close. So again, control divide gives me a fraction. I'm typing exactly as I have. So negative 30 minus 10 over 7 minus 1. Negative 20 over 3. Okay, but let's put that as a decimal. So if I push control enter, it gives me it as a decimal. So control enter will give me that at a decimal. Now, is that close to one of my answer choices?
Yes.
Which one? F. So that will be my answer. Okay, again, best represents, meaning I can pick points I think that are very close. I can find and see which one is close to them. Questions on that one? Okay, if we look at 52, it says the function y equals 3.75 plus a 1.5 when c x minus 1 can be used to determine the cost in dollars for a taxi rate of x miles. What is the rate of change of the cost of dollars with respect to the number of miles? Okay, now for this one, and an equation, and a linear equation. Okay, well, let's do this first. Rate of change, again, means I'm looking for the slope. Okay, now with that, in a linear equation, what is the slope always next to? The x. Okay, it's always is it the one being multiplied or the one being subtracted or added? The one being multiplied, right? Because it's always right next to it. So if I look in my equation without having to do any math, which one would be right next to that x being multiplied?
1.5.
1.5. So my answer is F. Okay, I don't have to do any work on that. Question on that? Okay, next one, 21. It's asking which of these best represents the rate of change of the maximum area painted with respect to the number of gallons of paint used. So again, I'm looking at exact points. Now, is it easier? So if we look, it's going through every single one. Okay, at every single time it touches, it's at an exact point. Now, using this point right here, or this point right here is going to be easier to find. My first or my second point? My second point, why? At the 1, right? It's easy, right? So if I use the origin, and I use my first point. Now, if I look, how much did I go up?
200.
Look at your scale. Now, we gotta make sure we got our scale, so 400, and we went over how much? To 1. My x value is 1. So then my answer is change of y over change of x, which is 400 over 1. So that comes out to be C. Okay, you can either do it by counting on your graph, or you can do what we just did. So our y2 minus y1 over x2 minus x1. Now we see, let's say, we use the second point as point 2, first point as point 1. Now what's the y value of your second point? 400. What's the y value of your first point? 0 over the x value of your second point, 1 minus 0. So 400 over 1. Okay. Either way it works. You can count by the graph or you can do it by putting it in the equation. Put your phones away. Questions on? Okay, next one. Okay, now again, you're looking for your rate of change. So my rate of change is my y2, or change of y over change of x, which is y2 minus y1 over x2 minus x1. So if I look, let's say this is our first point, our second point. What is the y value of your second point? These are our 2 points. X always comes first, y always comes second. So 39 minus what's the y value of your first point?
32.
32 over the x value of your second point
1.
minus the x value of your first
0.
point 0. So again, I can put this in my calculator and say 39 minus 32. Oops. Over 1 minus 0, and get that, which is my answer. So that's what I would go next problem. Okay, now I thought to do this too. Well, how do I get from 32 to 39? I add 7, 0 to 1, I add 1. Okay, both ways work. Doesn't matter. Okay, this way will always work though. So positive, what's that? Yes, you could have picked any other points. I just picked the first 2 points. Yes. Yes. Okay. This way will always work. No matter what, your y2 minus y1 over x2 minus x1 will always work. Okay. So that's for graphs. That's for table help for anything. That's why I'll show you both. Okay. Now we're getting into we're looking at equations now and seeing different graphs. Now, with this, the easiest thing really is just to graph them and to see which one looks like. Now, if we look at our, well, we're going back. Okay, so if I go home and I go to a new document and a new graph, we're going to go through and we're going to put in these equations. Now, if we look at our equations, are they y equals? No. Okay, so I'm going to erase my equal sign. So when I get to my graph, I'm going to push the delete, and it's going to pull up a menu. I'm then going to go to relation, which is 6. So go to your graph, delete, and then go to relation, which is 6. And input it in exactly as you see it. So if we look at A, we have y plus 7 equal sign, negative 3 parentheses, x minus 4. Does that look like my graph?
Yes.
Yes. Okay, so A is my answer. So I'm really just looking at what does it look like. Okay, do they look similar? Questions on how to do them in calculator? Okay, next one. For your next one, for 35, just cross it off. We're not going to do it. We're going to go to 33 next. Okay. So the researchers in Antarctica discovered a warm sea current under a glacier that is causing the glacier to melt. The ice shelf of the glacier has thickened approximately 450 meters when it was first discovered. The thickness of the ice shelf is decreasing at an average rate of 0.06 meters per day. Which function can be used to find the thickness of the ice shelf in meters, x days since the discovery? Okay, so there's some important information that we see. Okay, 450, what is that going to be?
Your starting point.
Your starting point, which is the same thing as our y-intercept. Good. Okay, then it says, go say the thickness of the eye top is decreasing. If it's decreasing, is that going to be positive or negative?
Negative.
Negative. And what is this 0.06? At an average rate of 0.06 meters per day. And an equation, what would that be? My rate of change of my slope. Good. So if I look, is my slope or my y-intercept next to the x? Which one's going to be right next to the x?
The slope.
My slope's always right next to the x. So if I know that my slope is going to be a negative 0.06 because of our keywords, which one can I already eliminate?
B.
C and D, because this 0.06 isn't a negative. Then I look, I just need the starting point at 450, which would be which one? A. Why isn't B right?
Then 0.06 is not your starting.
The 0.06, that would be multiplied to each one of these, that would be distributed, and that wouldn't make my starting point 450. Okay, so then I would be able to see that. Questions on that? Again, put them away. Okay, for 50, it says the table represents some points on the graph of a linear function. Which equation represents the same relationship? So if we look, okay, the problem that we have with this is last time we graphed this in a relation mode. Anytime you have a relation mode, you cannot, you can't look at a table. Okay, so we wouldn't be able to graph these and look at our table to see which one it is. So the first thing that we're going to look at is finding a slope. Okay, so we did put in our calculator our y2, our second y, so negative 196 minus our first y, a negative 268, divided by our second x, which is negative 14, minus our first x, which is negative 20. So when I put that in my calculator, I have to go back to calculate, control divide to give me a fraction, and put it in. So negative 196 minus a negative 268, making sure I'm putting the minus and the negative. Negative 14 minus negative 20. And I get a positive 12. So which ones could I eliminate, because my slope, remember my slope is the number attached to that x. I can eliminate f and g because my slope there is 1 over 12, which is not 12. Now, okay, so my second step was to eliminate what I can. My third step is to look, so my x goes with x, y goes with y. Okay, meaning I have 2 points here now left. I'm going to look at the point itself and see which one is up in my table. Now, even if you don't remember that our sign changes inside, not outside, all of that doesn't matter. X goes with x, y goes with y. So we're looking, do I have an x of positive or negative 20? Yes. A y should be 268. Yes. If I look at J though, my x here was 268. Well, my x's here are 268. So I see that my answer is H. Okay, remembering that x goes with x, y goes with y. And then from there you can look at your table. Questions on that one? Please. Allison, stop. Okay, last one. Okay, at a restaurant, jars of tomato sauce are stored in boxes in the pantry. Each box contains 8 jars of tomato sauce. A cook uses 2 jars from one box and is asking which function. Now, we know that there is 8 jars, so the 8 is going to go into the important. If it says a cook uses, am I going to be adding or subtracting? Subtracting 2 jars. So I look at my answer choices. It needs to have an 8 in it. Which one of these can I already eliminate? D, because it doesn't have an 8. And then right now I'm using 2, which we said is subtracting. Which one would then be my answer? C. Okay, again, no math is all about. Questions? Okay, please make sure your name is on it.